Okay, so here is my alpha robot that I'm working on. It is running off an Arduino Mega with the Adafruit motor shield on top. As you can see, it's just stacked on top of a breadboard. It's just cobbled together at this point. And it is being powered currently by this battery pack that you can use to power your phone, or definitely these little microcontrollers, as well as Raspberry Pi and things like that. And I'm using the Tamiya chassis here. It's the wheels and the gearing, as well as the double gearbox that you can see down here. The motors that I have in there are actually from Adafruit, because the motors that come with the gearbox from Tamiya are not rated. The voltage is not good enough for them to be run here. This wants something better than a 3-volt motor, so I've put in those from Adafruit. And at the very front here on my Alpha, I have an ultrasonic sensor that is allowing it to know whether or not it can go or has to stop. There's enough slots on this Mega, which is why I'm using the Mega, because my code actually will look left, right, forward, and backward, so that this robot can actually navigate itself around a room and not get stuck unless it goes, I guess, down into something or climbs over something that then prevents it from being able to back up out of it. And that's the little screaming light there that says, hey, I can't go anymore, because at this point there's no sensors on there except the forward sensor. So this robot, he can't go anywhere. But if I were to move this coffee cup, this robot will start moving forward until he runs into those D&D books right there, and he will stop. But you can see where the issue is, I think, on this Alpha, is that it is very, very slow. And it is very, very slow crawling because this dual gearbox here from Tamiya can be set to different gear ratios. And I thought, well, it should probably be powerful enough, I'm going to unplug this here, powerful enough to climb over something. And I didn't think I needed a lot of speed, but it turns out that more speed would be nice. So what's fantastic about this little toy kit that comes from Tamiya, when you buy the double gearbox, is it actually comes with gearing ratios for 4 different ratio and torque combinations here. So I went with this one here, the C, which is 114.7 to 1. That's the gearing ratio, which gives me 809 force per centimeter of torque, and 115 RPM. They call them rotations, but it's revolutions per minute, of course, same thing, right? I thought that would be enough, but 115 is awfully slow. So I think I'm going to go ahead and move up to this B gearing. It still gives me a little bit of torque, much less than half, right? Almost a third torque, but it gives me almost a third RPM faster, so I'm going to go ahead and try that out. It's quite easy to follow these instructions if you have not tried out the Tamiya gearboxes before. So this would be A, and the second one on this sheet is B. On the back side, there is obviously C and D, and you can decipher that even if you can't read Taiwanese or Japanese or whatever this is that I can't read, because right there's a little D. See that? And then it all says type D in English, all nice and friendly for you. So let's go ahead and get to that. We're going to use this one here. This is the B. So we're going to try to drop it down to that. All right, here we go. All right, so here is the stripped down version of the little robot that I have. Uh, I just grabbed a piece of wood and put these wheels on there because when you buy the actual toy kit that this thing comes with, it's got a plate that this builds on, and then I also, if you know anything about them, you can tell that this is from the universal plate kit, not from the kit that comes with it. The kit that comes with it, everything is gray like this. In the universal kit, everything is this putty color. But even the universal kit is not wide enough for their double gearbox. So that is a little bit of a problem, and I should have looked that up when I did that. So if you're looking to use the Tamiya kit for your chassis, realize that if you go with the double gearbox, which you really need to do if you want to be able to turn this thing, because a single gearbox, of course, is just a single motor that can either turn forward or backwards, so your robot can go forward or backwards, and that's it. Not very exciting, and doesn't add for a lot of intelligence into your robot. You're going to have to build your own chassis, or I'm sure that you can probably find some online that are made. This one is made a little poorly by myself. It was hastily thrown together. Just basically cut off a piece of wood, and then you can see I even kind of messed up the drilling holes. And if you look very closely, you can see that it's a little cockeyed as well. So when this robot runs, he kind of lists a little bit there to the right because one of these tensions is more than the other. And so that's something that I will fix as I go forward. This is, like I said, an alpha version of this robot, basically to make sure that I can run these Adafruit engines, motors, from the code going through the shield. So we're going to go ahead and disassemble this, and I'm going to take this piece off so that we can get in there and change the gearing. All right, so here we have the double gearbox removed from the chassis and the motors taken out of where they go in. So it's very easy to build this thing. When you get it, it's completely disassembled. It's actually like a model kit. You have to cut these plastic pieces out of a mold frame, and if you're like me, you want to cut down the little burrs that show up. Doesn't take very long to get it apart, and doesn't take very long to get it back together. So I'm going to go ahead and take these screws out, and then we'll have these individual gearboxes open here. All right, I thought it might be interesting to actually see it come apart. So I've backed these screws out here, and I'll just put them over here, like that, and the third one. And then this casing just will slide right off like that, and I'm going to turn it like this because there's some bushings that are in there that I don't really want to fall out. I don't want to be chasing those everywhere. And this gearbox is kind of cool to work on because, as you can see, it's half of it's still put together. So I can remove the gearing on this side and not affect the gearing that's on the opposite side. And there's one of the spacers that has come out. I'm going to put that over here so I don't lose that. And you can see the bushings that are in this half of the gearing. All right, so for each of the gearing ratios that are on the paper, there is a gear nut here, right, that has a little grub screw in it that needs to be a certain distance from the end of this shaft, depending on how many gears it's expecting to have on the short end. And in this case, in the original one, there were 2 gears. There was the drive gear here that actually grabs the nut. And then there was the second gear here that, when they fit into the other gears like this. These are the gears that get powered from the motor, and these are the ones that turn based off that power. The yellow one obviously turns this blue one turns this blue one, and then that blue one turns this yellow one. And that's how you get your ratios, right? Well, in this, for the B, for the 38.2 to 1, it's not going to use the same type of gearing. It doesn't need to go this way. So this locking nut here, this drive nut, needs to be moved a little bit. Right now I think it's 16 millimeters. It needs to be moved back to 13 millimeters. So I'm going to go ahead and do that, and then we will continue building this gear. All right, so I have adjusted this drive nut here to be 13 millimeters as opposed to 16. And so I can now, following the instructions, assemble this piece. So I know that the drive gear there is going to be connected to that. I know that offhand without even needing to look at the instructions. But then from there, I have to look at the instructions. So we have one of these gears with the teeth going in right there. And then we're going to have one of the blue gears on this end. And then on the shaft here that goes in the back, in this case, we are going to have a single gear on that. And we're going to put our little spacer back on that. And then it's going to fit in here, and this can be kind of tricky if you haven't done this before. It has to fit between the gears like so. So you have to kind of put them in like that, not expect that you can put one in and then just shove the other one on top. And then I just slide this gear case back together, and there we have it. So you can see, whoops, should have screwed them. So there we have it. You can see the two different gearings. So this one is now at the faster RPM at the 38.2, and we're going to go ahead. I'm going to go ahead and do the other one here in a second, and then we'll have them both ready to try out. All right, so here it is regeared so that the ratio is quite a bit less than what it was. But here's something I didn't really anticipate because didn't really pay attention to this before I decided to regear. And what you will note here is that there are two areas in this gearbox where a shaft can come through. Previously, the shaft was coming through this rear one, and now it is coming through the front one. So that means that if I were to put my treads on, they will not work. The treads are too long for the wheels. However, I do believe that when I initially made this, I made a similar faux pas right here, whereby it was too tight and I couldn't get the treads on. So by screwing up originally, it's actually going to work out for me. So I'm going to remove these wheels, unscrew these retainers here, move them forward, and I think that's going to be pretty perfect. All right, so there are the treads back on it. There still is a little bit less tension on this one than there is on this one, so either this cockeyed hole that I made in the front is causing that, or I didn't do a very good job measuring in the back here, and this side may be closer than this side, but it's going to work. It is definitely going to work. The teeth are grabbing the tread, which is the all-important movement piece, and it's tight enough on here that it's not going to fall off. So I think that's good. I'm going to go ahead and hook these back up, put my motors in, and we're going to give it another test. All right, and here we are, reassembled, as it were, hastily thrown together, prone to breakage. But we've regeared it. It's all back together, and I'm going to go ahead and move the coffee cup, and we're going to see. It definitely made the trip in a shorter amount of time, which for the robot that I'm making, I think is a decent speed. If I find that as I put stuff on it that it's too much load for it, then we may have to modify that some. It also might behoove me to connect an external power supply here. This is a power on this shield, which will supply power to the motors without using the 5-volt coming from the Arduino, which might also increase the consistency of the speed. But at this point, I think it's good. All right, well, thank you very much for watching this video. If you enjoyed it, please comment in the section below. If you didn't enjoy it, well, just keep those comments to yourself. Just joking. You can do what you want, say what you want, because it is the internet's. If you would like to see the progress of this robot, including the code, I'll be more than happy to post that. Just let me know. Also, I'm going to do some work, obviously, on this block of wood to make an actual chassis for this robot, as well as something that can hold the components and not just have them thrown on top. My next test for this robot will be to connect the other 3 ultrasonic sensors and give it the logic test just to make sure that it will turn left, right, go back, go forward. It's been a test that has worked before, but I was using something other than the Arduino at that time. I was using an mbed Nucleo, and it worked fantastic with that. But we're going to go ahead and put this into Arduino because this is a nicer, I think it has more ports to it, so I can keep adding stuff to this. This robot, I would like it to be able to respond to some gestures and things like that, but be intelligent enough to find its way around a room. All right, well, till next time.